Problem 151, Quantum Mechanics. The question is, two operators A and B satisfy the commutation relation. The commutator of H and A is equal to minus H cross omega B, and the commutator of H and B is equal to minus H cross omega A, where omega is a constant and H is the Hamiltonian of the system. The expectation value of A at T is equal to psi A psi in a state psi such that at a time t is equal to 0, the expectation value of A is equal to 0 and the expectation value of B is equal to I is. We have the equation of motion d by dt of the expectation value of A is equal to 1 by IH cross the expectation value of the commutator of A and H. We have from the problem, we can say that the commutator of A and H is H cross omega B. Similarly, we have d by dt of the expectation value of B is equal to 1 by IH cross the expectation value of the commutator of B and H. From the problem, the commutator of B and H is equal to minus H cross omega A. Now let us substitute these values. D by dt of the expectation value of A is equal to 1 by IH cross the expectation value of H cross omega B, and that is equal to omega by I into the expectation value of B. Similarly, we have d by dt of the expectation value of B is equal to 1 by IH cross the expectation value of minus H cross omega A, and that is equal to minus omega by I the expectation value of A. Now take the second derivative, d square by dt square of the expectation value of A is equal to omega by I into d by dt of expectation value of B, and that is equal to omega by I into minus omega by I expectation value of A, or we can say it is equal to d square A by dt square minus omega square A is equal to 0. Therefore, the solution is the expectation value of A is equal to C1 e raised to omega t plus C2 e raised to minus omega t. In the same way, we can say that d square B by dt square, that is equal to minus omega by I into d by dt of the expectation value of A. Substitute the value of d by dt of the expectation value of A from the left side. We will get d square B by dt square minus omega square, the expectation value of B is equal to 0. Therefore, the expectation value of B is equal to C3 e raised to omega t plus C4 e raised to minus omega t. It is C4 e raised to minus omega t. Now we have the expectation value of A and B. It is given that at a time t is equal to 0, the expectation value of A is equal to 0. Therefore, we can write 0 is equal to C1 plus C2. Similarly, at a time t equal to 0, the expectation value of B is equal to I. The expectation value of B is equal to I. Therefore, we can say I is equal to C3 plus C4. Now take the differential, that is d by dt of the expectation value of A, that is C1 omega e raised to omega t minus C2 omega e raised to minus omega t. From the previous section, we know that the value of dA by dt is omega by I expectation value of B. Now let us compare these two equations, and at t equal to 0, we have C1 omega minus C2 omega is omega by I into the expectation value of B at t is equal to 0 is I, and from this we will get the expression C1 minus C2 is equal to 1. Now let us give the proper equation number. The first equation as the equation number 1 and the second equation as the equation number 2. And from the equation number 1, we have C2 is equal to minus C1. From equation number 1, we have C1 is equal to minus C2. Now substitute the value of C1 in equation number 2. We will get 2C1 is equal to 1, or C1 is equal to 1 by 2. When C1 is equal to 1 by 2, we have C2 is equal to minus 1 by 2. We have the expectation value of A is equal to C1 e raised to omega t plus C2 e raised to minus omega t. Now that is equal to 1 by 2 e raised to omega t minus 1 by 2 e raised to minus omega t. That is equal to sin h omega t. Therefore, option 2 is correct.